Good morning, good afternoon, depending on your time zone. Thank you guys for joining us. I'm David Kanter, the one of the founders of MLCommons, head of MLPerf. Many of you I know from a past life. So this is a briefing about MLPerf Client 2.0. I just want to remind folks this is under embargo for about a week until the 18th at 8 a.m. Pacific time, at which point we really hope you will pour forth as many words, video, audio as you can. So thank you for joining us. With me here, I've got two of the working group chairs in case we get sort of more detailed technical questions. They are here as MLCommons representatives, not as representatives of their companies, but Yanni Yoki is from NVIDIA and Ramesh Jalati is from Intel, and they have helped to lead the MLPerf client work. Um, yeah, so this is just an overview of what we'll be talking through. So we're going to go through in an abbreviated fashion the first two sections and really try to focus in on what's new in MLPerf Client 2.0. All right, next slide, please. Okay, background about MLCommons. You know who we are. Global collective engineering spanning the whole industry. We have tens of thousands of results, and the focus today is, of course, on MLPerf clients. Next slide, please. This is just goals of good benchmarking, things like reproducibility, representative workloads, and I think the most important thing here that MLCommons really brings to the table that I do want to emphasize is the transparent, fair, and robust process, right? That bringing everyone to the table in an open and transparent and jointly negotiated process produces better outcomes than simply throwing something against the wall. Right. Anyone can build a benchmark by running something and timing it. And, sometimes that's the best benchmark that you can do because it's reflective of what you're doing. But if you want to build an industry standard that generalizes, then I think you really need to be following the sorts of processes that MLCommons has developed and specialized in. Next slide, please. All right, this is sort of an overview of the various MLPerf portfolio benchmarks. We're, of course, focusing on MLPerf Client here, but we have a wide variety of things, including training, and then storage is storage focused, and almost everything else is focused on inference in various flavors. So covering different parts of the ecosystem. One that I'll just call out is MLPerf Endpoints is a new data center oriented benchmark that is focused on sort of modernizing MLPerf inference for the modern data center. And actually pairs nicely with MLPerf Client, which is, very much focused on client devices. All right, next slide. So, MLPerf Client Working Group, this is the folks who we collaborate with closely here. MLPerf Client is, of course, open to everyone, although, there are some silicon vendors who have chosen not to participate at this time. But it is a very good collaborative effort and spirit. I'm really proud of this group, especially given that a lot of client benchmarks and it is a fiercely competitive ecosystem, but I think everyone brings their enthusiasm for competition to collaborate here. And you can see, as I mentioned, we've got two of our working group chairs, Ramesh and Yanni, with us today who can help answer questions. Next slide, please. All right. So, uh, background on MLPerf Client. I think you are all fairly familiar with it. I want to just emphasize, cross-platform and installable application, collaboratively built and open source. And I think the open source nature is actually very important, and that degree of inspectability is both extremely convenient for the industry and also gives it a level of maturity and robustness that is really quite welcome and differentiated. And I think in comparison to some of the other MLPerf benchmarks, there is a bit of a focus on sort of simpler, easier to understand benchmarks, in part because this is targeted at end customers, and they may not always have the wherewithal to decipher sort of the complex set of results that you see in sort of data center benchmarks, where there's a lot more trade-offs. And so, just as an example, I think there's sort of a default assumption on MLPerf Client that you just have one user interacting with the application. Whereas in the data center, you're often serving hundreds or thousands of users. So that just lends itself to simpler and more straightforward metrics. Next slide, please. Um, so the why, I think one of the biggest inflection points that we've seen lately is OpenClaw, right? Where we're seeing sort of the vanguard of folks really, really shifting into using AI locally, oftentimes in complement to the data center or perhaps sometimes instead of. And realistically, we see that as the start of a trend. And even though when you buy a system today, there may not be a huge number of applications that are going to be using AI immediately, most client systems will have a useful lifespan of 3 to 5 years, maybe even longer if it's in a business context. And you can be guaranteed that, 3 years is an eternity in the AI context. And I am pretty certain that, 3 years from now, even 2 years from now, we're going to see a lot more usage on client systems than we did before. And I think there's still an open question of, how much do people run locally only or sort of hybrid, local and in the data center? Because some of these workflows are just beginning to emerge, right? Agentic is still a very new thing, and I don't think there's sort of settled consensus on exactly the right way to handle agentic execution. But the key uh, goals are giving us, again, a neutral and transparent standard and like for like measurement context so that you can actually compare the results. Uh, Next slide, please. Um, so I think we introduced this in the past, but we're leaning into it a little bit more here. Within MLPerf Client, we have three flavors of workload: the base, extended, and experimental. And I want to be very clear about what those mean. So, first of all, regardless of where a workload falls, you should assume that that workload is extremely robust and well characterized and well understood. So, this is not beta workloads, but the base, extended, and experimental instead is denoting for base, these are workloads that we believe should run everywhere. And that includes small laptops that have, very tight power constraints up to systems with discrete accelerators. So on extended, those are going to be larger workloads that may require capabilities that are not in all systems. So again, this is really about the breadth of system support rather than the maturity of the workload. And this is just the reality of if you want a benchmark that works on all client systems, there's a fundamental difference between something with a 400 watt accelerator and something with a 15 watt power limit, right? Uh, and then on the experimental side, that is for newer workloads where the support may still be just rolling out throughout the ecosystem. And there's a constant tension within MLCommons. And one of the biggest challenges that I think as an organization we face is how we handle the rapid velocity and development of new workloads. And so experimental is our solution for MLPerf Client. And so when new workloads come out, they will often first be an experimental, and then once the ecosystem support and the platform support has broadened, they will sort of graduate into extended or base. Does this make sense for anyone? Please feel free to jump in if you've got questions. All right, straightforward. Great. Next slide, please. So the metrics we're using on the LLM side is time to first token, which is going to be measuring essentially pre-fill. And then your tokens per second for subsequent tokens, which is measuring sort of the decode rate, right? So time to first token, how you handle the full initial prompt, page everything in, and then you know the decode is generating your follow-on tokens, and that will incorporate things like KV caching, etc. On the image generation side, we're using images per minute, primarily so that we get a bigger is better number. Um, and again, that's something that was done to aid in the interpretability. And then for our new agentic benchmark, it's simply end-to-end duration. And so the total execution time of the agentic trajectory, which includes both inference and conventional tool calling. And so their lower is better. All right. Uh, the, and actually, just jumping back to the image generation, I think one of the other reasons why we're using images per minute is there's sort of a default assumption that when you are generating images, typically you're going to be generating a batch of images to select from them. If you think about sort of interactively how you work with an image generation system. All right, next slide, please. So this is our sixth release in about 2 years. I'm absolutely thrilled with the cadence that we've been able to maintain, especially for an industry standards organization. You don't get to necessarily move as fast in an industry standards org, but I'm very proud of how fast we are moving, and I think it's actually something very special that MLCommons brings to the table. Um, this is sort of a recounting of what we've done in previous versions, and 2.0 is really building on this with a couple of key changes. So next slide. So when we look at the critical things that were done in MLPerf 2.0, it is adding in Flux 2 as our new image generation model. We're extremely happy with this because it is a much more modern model, and it is, very much state of the art, representing what people use. We added in a new agentic benchmark, and again, I'm super proud of how quickly the group was able to get this incorporated in, given that agentic workloads only became a thing very recently. And this is part of our commitment to, really trying to stay abreast with innovations in the AI world. We also updated our LLMs to be a bit more modern, and then have made some what we call quality of life improvements in sort of how the application, data export, etc. work. Next slide, please. So, on the LLM side, we have a wide variety of categories of prompts, and then we have a selection of models. As you can see, some of the models, the larger 5 for reasoning, 14 billion, that's an extended. Qwen 3, 8 billion is an experimental. And then each of these will run in base, you will run all of the base prompts. If you're in extended, you will also run the extended prompts. So this tells you what's being tested as part of the benchmark suite. Any questions here? Okay, next slide, please. So, um, we have introduced IFEval as a accuracy test set, which is helpful for agentic workloads and also more fully inspects the output than MMLU. And then for the image model, uh, the uh, the output is actually inspected visually by people when we build the application. So it's gone through an accuracy check to make sure that the outputs are realistic. And this is an example of something that we actually had some real challenges with in MLPerf inference when the first image generators came out, is that you could get an image model that, according to quantitative metrics works fine. But when you look at the output, it's totally unusable. And so, again, here we're doing visual inspection ahead of time to make sure that everyone's solution can hit the right quality. Uh, Next slide, please. So now we get to dive into the fun part, which is our agentic testing. And so this is, I'd say our biggest innovation in 2.0, and perhaps the most topical as well. So we have two different scenarios that we are analyzing. The software engineering agent is in base, and then the data analyst agent is in experimental. It uses the models shown below. And one of the things that I want to emphasize is that the measurement here is not just the inference portion, but is the full trajectory. So I believe overall we're looking at something like in the neighborhood of 5 turns. So sort of relatively smaller agentic flow with, I think, roughly three model calls and then two tool calls that are stitched together to form the agentic flow. Now, this means that we have both portions that are very easy to accelerate. The model calls will, of course, with the right software stack, use an accelerator. And then the tool calls will primarily run on the host processor. And the balance between the two will vary based on your system, right? If you have a very high-end accelerator, Amdahl's law says all of a sudden the CPU matters a lot more. So just something to keep in mind as you're testing. And also, this is representative of real agentic workflows. Uh, Next slide, please.
Yeah, real quick on that one, just to
Yeah,
clarify, is wall clock the only metric you get for this, or do you also get the inference metrics as part of these tests?
that's a good question. Yanni or Ramesh, do we output the sort of components of the trajectory?
Yeah.
So
Yeah.
the overall score gives you the total time and the tool time. So the difference is the inference time. If you want to look at the inference individually, you'd have to go into the log file. That's not something that the benchmark reports,
Yeah.
but
Okay,
it's there if you want to dig it.
sure. Okay, thank you.
Yeah. And I guess just Ken, just asking the question from your perspective, is that something that you look to call out, or how do you sort of think about this?
I think the end-to-end time makes the most sense. It's
Mhm.
just, more of a curiosity for as we start to run this and dig into things, what data is available to look at and kind of start to determine differences between platforms. Like if you're running on, you know, very similar CPUs with identical GPUs or vice versa, just, there is going to be that distinct break there, and just wondering if you could kind of dig into it further. It sounds like there is possibility there.
Yeah, I'd say philosophically, um, within MLCommons, generally our approach is to make, to try to record all the data that we can, but then be very careful about what we want to highlight as an official metric, right? And clearly, the end-to-end time is most reflective of what a user is going to experience. But to your point, the subcomponents can be particularly interesting. And there are reasons why it absolutely makes sense to want to understand, what's the tool time breakdown, what's the model call time breakdown, and so forth, especially in a nascent field like agentic benchmarking. right? It's entirely possible that a year from now, we might come back and say, okay, actually, the industry has really reached consensus that we do need to report these and call them out separately. I mean, I suspect not, but you know, in AI, predicting the futures can be a very hazardous occupation.
Very much so. Thanks.
Um, yeah, but great question. All right, next slide. So this is, I've already stolen a little bit of the thunder here, but this is a deep dive on how the agentic tests are structured and what they're doing. Just a few things to call out here. You know, the input sequences are significantly larger than what we've had before, approaching nearly 30,000 tokens. And the sort of scenarios that are modeled here are written up, right? For the software engineering, that means you're going to be looking through files, patching code, running the compiler, and then making sure that everything passes. And then on the data analyst side, sort of similar, you're going to read in a data set, start aggregating the results, and generate some charts. Um, One of the things I do want to call out here that is in the text is that the we have verified the accuracy offline, but that the accuracy results during the agentic run are essentially not collected, right? And so this is timing performance only, and the outputs are discarded in the agentic trajectory. And that is something that is necessary to make sure that it's comparable and reproducible in terms of actually, you know, if you had something that had a 5% failure rate, you know, then all of a sudden 5% of the time you would need to rerun things, and that would get potentially quite challenging in a benchmarking and measurement context. Um, in the long run, there may be ways to start incorporating more complex tasks, trajectories, and bring accuracy in as a first-class citizen, but that's not what we're doing here. And I want to be honest about that and also call it out. And hopefully the reasoning resonates with everyone. So, are there any questions about that? Okay, great. Next slide then. All right, here are the details on our new image generator. Um, uh, this is in experimental, and so just as a reminder, that means that it may not be fully optimized on all target systems, but it is a wonderful cutting edge model that does produce great outputs, and we're really excited to be adding it to the benchmark suite. So, yeah, next slide. Right. So we've got 4 prompts. I think, Yanni, you have a pet cat. Is that why we got a cat instead of a dog?
No, but image generation classically requires one cat. So
Oh,
hence
okay.
we have the cat. And I
I,
do have a
I'm a
cat, but this is not mine.
I'm a dog person, not a cat person. So, you know.
Well, we allow you to be wrong.
And also allergic. But yeah, so we've got 4 prompts, and then they're all submitted in a blend to get the throughput, the images per minute. Um, and just as a reminder, each submitter is likely using a different backend. So, and then the resolution is 1K by 1K. And the runtime is about a minute. And again, a lot of this is picked to make sure that the runtime is realistic, but also feasible for everyone doing the testing. Next slide. All right. The LLM updates, as I mentioned, we've got much more modern models here. and then the task has been tweaked slightly. And then the other thing I want to call out is that the 4K prompt length is now part of the base specification. So, that's a significant change prior to relative to prior versions and sort of reflects the increased capabilities over time. And I would anticipate that in the future, we would also see longer prompts and more complex prompts as well. Next slide, please. All right, here are the inputs and outputs. And as I mentioned, the intermediate summarization with 4K length, that is now in base. And then the 8K extended prompt is not reported in the overall score because that is part of the extended specification, so that's reported separately. All right. Next slide. All right, here is the platform support. So you can see every platform has an accelerator that is supported, and in several cases, there's multiple different combinations that are available. And in most cases, there are at least two different options for the frameworks and runtimes. This is just how to play with the client. And just as a reminder, there is absolutely a CLI there for folks who would like to use it. Any questions for us